is the physical science lesson video for section 20.2, and as always, if you want my videos in one spot, then just subscribe to my channel. So we're going to talk about electric current, and we're going to do some Ohm's law in this section. So a continuous flow of electric charge is an electric current. The SI unit for electric current is the ampere, which you'll hear called amp, but it's abbreviated as capital A. Okay, so like when we do math with it, we're going to put capital A, we're not going to put AMP for amp. It equals 1 coulomb per second. If you remember from a previous video, coulomb is our unit for charge. There are two types of current, and they are direct current and alternating current. If you ever heard of AC and DC, direct current is DC, AC is alternating current. So direct current, charge only flows, wow, that charge only flows, I guess I don't need flows twice, right? Charge only flows in one direction in direct current, which is also known as DC. A flashlight and most battery-operated devices use direct current. So if you look, the current only flows in one direction, so it's constantly in this direction right here. That would be direct current. Alternating current, or AC on the other hand, is the flow of electric charge that regularly reverses its direction. So if you look, we have our current traveling this way, but then we have it traveling this way. So direct current stays in the same direction the whole time. Alternating current, it's going to switch directions or alternate directions. Electrons flow from the negative terminal of a battery to the positive terminal of a battery, which makes sense because electrons are negative, so would they want to go toward another negative or towards a positive? Well, remember, like charges repel, so it wants to get away from the negative, and opposite charges attract, so it wants to get to the positive. The current is in the opposite direction because current is the direction in which positive charges would flow. Okay, so that's where it gets a little tricky. So here we have the direction of the electron flow. So remember, we're going to go away from, there's a negative right here. We're going to go away from the negative toward the positive. That's the flow of the electrons, but they have picked to show current as the direction a positive charge would flow, even though what's flowing is electrons. I didn't get a pick how they do this stuff, I just teach it. Alright, so the direction of the current is from the positive to the negative, even though our electric charge is from negative to positive. I know it's a little confusing. So let's talk about the difference in conductors and insulators. An electrical conductor is a material through which charge can easily flow. Examples include copper, silver, and most metals. Those all tend to be good conductors. A material through which charge cannot flow easily is called an electrical insulator. Examples include wood, plastic, rubber, and air. So those are examples of insulators. So since metals are conductors, that's why you don't want to try, like if something's caught in an outlet, you don't want to use metal tweezers to try to pull it out, because of course that electricity will pass right through and you'll get electrocuted. However, if you were to use something like pliers that have rubber or plastic handles, then the electricity would not pass through that. So metals tend to be electrical conductors because they are made up of an ion lattice. The positive metal ions cannot move, but the electrons can move. This mobile electron lattice is known as the electron C model. Alright, so in normal compounds or substances, you have each atom or ion and it's attracted to one another, but the electrons remain with that one nucleus. When we're talking about a metal, you have your positive metal ions, and the electrons can just kind of travel around whichever ion they want. Okay, so in other words, the electrons are able to move. And remember, what is flowing in electricity? Electrons. That's why we talk about the path of the electrons. So as long as electrons can move, the material will be a conductor. As electrons move through a wire, they collide with other particles, which convert some kinetic energy into thermal energy. That's, for example, if you hold two ends of a wire onto the terminals of a battery, you'll feel it heating up. Okay, because remember we've talked about friction and things like that creating thermal energy. Well, this would also create thermal energy. Resistance is opposition to the flow of charges in a material. The SI unit for resistance is the ohm, which is represented by omega. A material's thickness, length, and temperature affect its resistance. Resistance is greater in a longer wire because the charges move farther. Remember, the the electrons are going to bump into those metal ions in that lattice. So the longer distance it has to travel, the more times it's going to bump into one of those ions. As temperature increases, a metal's resistance increases because electrons fly more often. Remember, when something is heated up or temperature increases, the particles are moving faster. Faster particles means more collisions. It would be like if you're in a really, really busy hallway at school during class change. If you're just casually walking, you can easily, step back and forth and probably not bump into anybody. But if it's class change time and everybody's running, then, because we've sped up because of an increased temperature, if everybody's running, you're more likely going to bump into each other at that point. A superconductor is a material that has almost zero resistance when it's cooled to low temperatures. Because as you can imagine, we want all of our electricity to do work. We don't want to waste it with thermal energy that's not what we want. So if we can get something that has low resistance, that means we get more use out of it. In order for a charge to flow in a conducting wire, the wire must be connected in a complete loop that includes a source of electrical energy. So we're going to start talking about circuits here. So we have to have a complete loop. If there's a break in the loop, so see, we have our complete loop, but here the switch is open, there's a break, the light bulb will not light. Okay, so it has to be a complete loop. And then you obviously have to have some source of energy. In this case, we have a battery right here. Potential difference is the difference in electrical potential energy between two places in an electric field. Potential difference is measured in joules per coulomb, or volts, which is represented by a capital V. Potential difference is also called voltage. So voltage is represented by V. Charges flow from higher to lower potential energy. You never want an excess of energy. So if you can get to lower energy, that's always preferred in science. Three common voltage sources are batteries, solar cells, and generators. A battery is a device that converts chemical energy to electrical energy. So inside a battery, you have chemicals. It depends on which battery you're looking at as to what the chemicals are. And so that's how a battery dies, is eventually the chemical reaction has gone to completion, and so you can't produce any kind of energy from the battery any longer. According to Ohm's law, the voltage, which is V, in a circuit equals the product, so of course product is multiplication, of the current, which is represented by I, and the resistance, which is represented by R. So be careful. I know the font I chose is probably not the best. So this is a capital I. It's not a lowercase l. So in other words, your voltage equals current times resistance. And so remember, voltage is going to be in volts, or V. Current is going to be in amps, or a capital A. And resistance is going to be in ohms, or the omega symbol. So, section assessment. List two types of current. Well, you have alternating current and direct current. Alternating current and direct current. Number 2, name 2 good electrical conductors and 2 good electrical insulators. Well, for conductors, you could say copper and silver. Really, pick almost any metal. Copper and silver. For 2 good electrical insulators, you could do plastic and rubber. Plastic and rubber. There are others besides those examples I just gave you, by the way, but those are just 2 that I know we just discussed in the PowerPoint. So what variables affect the resistance of a material? Well, it's the length, the thickness, and the temperature. The length, the thickness, and the temperature. What causes charge to flow? A difference in potential energy. It's called potential difference. A potential difference. All right, number 5. According to Ohm's law, how is voltage related to resistance and current? Well, you could just put the formula, V equals I times R, or you could say that voltage is directly proportional to resistance and to current. Either one would be fine. So V equals I times R, that's the actual formula for Ohm's law. Or you could say voltage is directly proportional to resistance and to current. Next one, suppose you have 2 wires of equal length made from the same material. How is it possible to have different resistances? Well, resistance is based on length, thickness, and temperature. So it says they're the same length, but it doesn't say anything about thickness and temperature. So they could have different thicknesses, or they could have different temperatures. Okay, if thickness or temperature is different, that would cause a different resistance. All Alright, and the next one, use Ohm's law to explain how two circuits could have the same current but different resistances. Well, remember, Ohm's law says V equals I times R. So if they have the same current or the same I, but different R's or resistances, that just means they're going to have different voltages. So your V's would be different for both of these. Alright, so hopefully you understand a little bit more about the flow of electrons in a circuit and the difference in alternating and direct current, and a brief introduction to Ohm's law. We didn't really do any examples, but we will do some math in the next video.